Hello, here's the second part of the video on 1.5, and this part is more theoretical. It's a couple of things that if you take calculus, you'll see again, and so we're introducing them to you now, and then there's something that we'll see later on in the course when we get into trigonometry. Okay, so again, these things, this increasing, decreasing, it looks like a lot, but it's actually fairly intuitive, and so don't make it more complicated than it needs to be. Okay, so right here, we're going to see if a function is increasing, that's where it's going up. It's no more complicated than that. A function is decreasing where the graph is going down. Okay, and then we want to find a relative maximum, and that's really just a point that's higher than anything near it. So it's a turnaround point that's high. And then here, this is going to be a turnaround that is small or low. That's going to be the smallest point where it turns around. Okay, so let's look at this. Okay, the relative maxima are here. That's a high point. It's where the graph turns around there. And here is another place where the graph turns around high. So these are the two maxima, x2, and then over here, x4, y4. Now the minima are the low points, and notice it's, again, these are places where the graph turns around. And what happens is these are the low points on the graph, at least close by. And so those minima are going to be x1, x and y, coordinate x1, y1, and then x3, y3. Now notice here that we specify, this is important, this is a good tip, we specify a point. Now what we're going to see down here is for the, as when we talk about increasing and decreasing, we're going to specify x values. So this is just a technicality that you want to be careful of. Sorry, it's supposed to be an x. Here, I can write that neater. That's pretty ugly. Sorry. I know it's hard to write with these things, but I can do better. So here we're going to specify an x value. Okay, so the function is increasing where it goes up, so it's increasing between x equal 1 to x equal 2, and that's how we get this. And then it's increasing between x equal 3 and x equal 5. And that's how we get, I'm sorry, x equal 3, here, let me draw that again. X equal 3, and then x equal 4. So it's increasing from there to there. So that's how I get this and this. And now we want to see where it's decreasing. It's decreasing between x equals 0 and x equal 1. It's decreasing between, right here, between x2 and y2. So we write that interval in between x4 and y5. And one thing I didn't make clear, but I want to do that here, is that these points are on the graph. When you don't specify the endpoints, and if you don't see like an open circle or a closed circle, assume it's a closed circle. Okay. Okay. So let's do a problem. We want to look at a problem that we did earlier, but in a different context. We found the domain and range earlier. We want to find where this is increasing, so where it's going up, where it's decreasing, maximums where it turns around high, and minimums where it turns around low. Okay, so think about that, try to get the answer, pause your graph, and then when you're ready, resume. I'm going to go to the next slide, so you should pause. Okay, so here's the problem. So again, we want to figure out where it's increasing, where it's decreasing. Notice that 5, 2 is not on the graph. So it's increasing between, so it's going up between x equal minus 1 and then x equals 0, x equal 0. And then again between x equal 2 and x equal 3. I'm sorry, x equal 2 and x equal, but not including 5. So from here to here. Okay, so this tells me it's increasing between -1 and 0. -1 is included, and between 2 and 5 is not included, so we use the parenthesis. Okay, so now we want to find out where it's decreasing, and if you look at it's decreasing from 0 to 2, so it's going to start at x equals 0, and then it goes down till we get to x equal 2. So that's the only interval on which x is increasing. And remember, this should be a 2 here. Sorry about that. I wrote the y coordinate by mistake. Again, so notice that we did for increasing and decreasing here that we gave x values. And then for minimums, we're going to give the points in the form x, comma, y for these. Okay, so where's the function turn around? There's a couple of places. There's 3. Here's a high turnaround, so the maximum is 0, 3. And here's a low point right here, 2 minus 3. So that's going to be the relative. So now we're going to ignore the endpoints. So don't worry about those. Okay, so on to the next concept. It's going to be rate of change of a function. And just so you understand if you're looking at the graph, the red is going to be the function. That's going to be the graph of y equal f of x. And then the blue is going to be the line between 2 points. And I'll go into more detail about what that means. So that's blue, the line between 2 points, and red is going to be y equal f of x. Okay, so on this graph, I just want to identify some points. This is going to be x2, y2. That'll help us understand the formula. And then this is going to be x1, y1. We'll name these points for an example in a minute. Okay, so we want to find the average rate of change of a function. It's defined to be the change in y over the change in x. And remember that y, if we take x2 and plug it into the function, that gives us y2. So that's where that comes from, and that's where that comes from. So basically, this is going to be the change in y over the change in x. And we'll go into why that is. So this is called the average rate of change. Okay, and we'll do a question in a second. So here, let's look at this picture. I'm giving you 2 points. Let's say this point is 325. And then this point down here is going to be 27. Okay, so the average rate of change for the functions is 25 minus 7. Those are the y coordinates. X coordinates 3 minus 2. Sorry, this should be an equal here. And then that's going to give me 18. Now notice that that's also the slope of the blue line. So I'm going to say that that's equal to the slope of the blue line. So I'm going to talk about how that relates. The blue line is called the secant line of the function. Now what happens here is the function, notice how it doesn't increase at the same rate. It keeps getting steeper. So it doesn't have a rate of change over an interval. It has an average rate of change. So this 18 means between x equal 2 and x equal 3, the function on average increased by a factor of 18. Okay. Now the line between these 2 points I said is called the secant line. And so to find the rate of change is the same as finding the slope of the secant line. And again, since we can't, sorry, this is a secant line. And again, since we can't find the exact rate of change at a point yet, you can do that in calculus, but not yet, that we need a way to talk about the average rate of change. Okay, so here's an example. Let's find the average rate of change here. Sorry, this got cut off, but that's 3, f of 3. Okay, so I'm going to use this formula here and try to find the average rate of change. I want you to try the problem, and then move on to the next slide for the answer. I'm going to go to the next slide. You should hit pause. Okay, so find the average rate of change. So again, we're going to use, this is called the difference quotient, but we don't need that. You can just call it the average rate of change. You want to use this formula. And if we plug in x1 equal 2 into here, we're going to get, this is f of 2, and we plug that in, we get 2 cubed minus 2, which is 6, plus 1 is 7. And then we plug in x2 into here, we get f of 3, that's going to be 3 cubed minus 3, so 27 minus 3, 24, plus 1 is 25. So what we get here is the average rate of change between these 2 points is, according to this formula, 18, so cut and dried. So again, that's going to be the slope of the secant line. And this is the same picture, remember, that we had before. This is the point 325. And then this is the point 27. Okay. So again, that tells us that as the function goes from here and here, it's changing on average by a factor of 18. Okay, so we'll go on to the next one. And the last topic is even and odd functions, and they come into play in trigonometry. So a function is even if when you plug in the negative, you get the same as when you plug in the positive. Now it's odd if when you plug in the negative, you get opposite. Now, I think it's easier to use this formulation. So a function is odd if minus f of minus x is f of x. I think that's the best way to do it. So here's the question. If we want to find if this function even or odd or neither. A function doesn't have to be odd, and a function can't be both. So I'm always going to start by plugging minus x into here. And then first I'm going to look at minus g of minus x and see if minus g of x is equal to g of x, in which case that's odd. That's what we get from here. And then I'm going to plug in minus x into g and compare it to g of x. And if that's true, if those two are equal, it's an even, because you get the same if you plug in the minus or the positive. And if neither is true, then the function is neither odd nor even. I'm going to let you try to answer that. The answer's on the next slide, so I'm going to hit pause. You should hit pause. I'm going to go to the next slide. Okay, so here's the answer. Is this function even, odd, or neither? So again, I'm going to start using the same thing. So I start with g of x here. I plug in minus. I'm going to take minus g of x. So I plug in minus x. I get minus x cubed minus minus x. The cube of a minus number is minus times minus 3 minuses, so we still have a minus. And then here a minus negative is going to give me a plus. So I haven't applied the negative sign yet, but this is equal to this. And now I apply the minus, and I get minus x cubed minus x. And notice that's the same here. So the function is odd. Okay. Now we'll do another one. Here's another example. And again, I'm telling you what you need to do. I'm going to hit pause. You try it. And then let's look at the answer on the next slide. So I'm going to go to the next slide. So pause it and then rejoin me. Okay. Is this even or odd? So again, I'm going to plug in, I'm going to do the minus h minus x. I'm going to plug in minus x, and I plug in minus x for x squared, and I get x squared because minus times minus is positive. So again, what's between the big brackets, that's going to be here. Now I apply the minus sign, and I get minus x squared. That's not equal to this, so it's not odd. So that doesn't happen. So now I'm going to test for even. I'm going to plug in minus x. And again, I'm just seeing if h of minus x is going to be equal to h of x. So I plug in minus x, I square it, I get x squared plus 1, and that is equal to that. So h of x is an even function. So this happened. Okay, so let's do one more. Then we'll talk about these. Is that even, odd, or neither? Again, try it. Plug in x minus x and compare it to f of x. See what you get, and then the answer's on the next slide. I'm going to hit pause, you try it, and rejoin me in a minute. Okay, so is that even, odd, or neither? So again, I'm going to plug in minus x, and I get minus x plus 1 when I plug it in. Minus x squared gives me x squared. Adult plus minus is minus, and then still I get a plus 1, so this becomes this. Then I apply the minus, and I get minus x squared plus x plus 1. That's not equal to f of x, so it's not odd. So that doesn't happen. Let's see about even. Plug in just minus x squared minus x plus 1. I get a minus x squared plus minus x is minus x plus 1. Again, that's not equal to this, so it's not even. So that's not going to happen. Therefore, since neither is true, the function is neither odd nor even. Okay, and that's about it. So those are 3 examples. Now I'm going to ask you on the next slide a question. There's a shortcut you can do, and it has to do with the exponents. And if you think about it, you'll of course, that's what it has to be. So review your answers, go to the next slide, see if you can look at the exponents and figure out if the function is even or odd. So hit pause while I go to the next slide and then resume. Okay, so let's look at all the examples. Here's the h of x. And notice that I'm going to rewrite 1. Remember, x to the 0 is 1. So what that means is that if I take any number times x to the 0, I get that number back. So if I get 3x to the 0, I get 3. If I do 1, that's going to be the same as 1 times x to the 0. And notice that 0 is an even number. So both of these exponents are even. Now let's look at this odd function. Again, x is equal to x to the 1, so here I get both exponents are odd. And the function's odd. And then here I have neither, and notice it's a mix of even and odd. So that gives us kind of a shortcut. If all the exponents of a function are even, the function is even. I want you to think about that, but still you still need to do it the long way by plugging in x and minus x and comparing. If all the functions are odd, if all the exponents are odd, the function is odd. And if some exponents are even and some are odd, the function is neither even nor odd. Okay, that's it. So if you have questions, bring them to the next class to either me or Professor Akbuga, and we can talk about this. Okay, thank you. Bye-bye.